Hi, this is my model of the melanocortin 1 receptor. This is the normal one, and this is the mutated. For my model, I use pipe cleaners to mimic the spirals and the straight lines of the protein itself, the little tough part being the spirals of the protein. For my model, I used the beads to model the amino acids.
Sit up here just like this. She play. At night, when I heard the people screaming, she told me.
And for my mutation, I used a purple little puff ball to show the mutation in the cysteine. And then up here, I used a red bead to show the regular, which is the arginine. Melanocortin 1 receptor has two subunits, eumelanin and phenomelanin. In a normal melanocortin, it has eumelanin, which means that there are a lot of pigmentation, which leads to a darker color. Phenomelanin is shown more in the mutated version of the protein, which means that there is a lot less pigmentation, which leads to a lighter color. This is all because of a change in amino acids from arginine to cysteine, 67. Eumelanin is represented as this red bead, which is the arginine, and the phenomelanin is represented by the purple puff ball, which is the cysteine, which shows the change from red to purple. In a normal MC1R, the presence of arginine 67, which allows the protein to be more active, produces more eumelanin because it can bind to alpha MSH. In the mutation, the replacement of arginine 67 with cysteine 67 causes the protein to become less active and creates inability to bind to alpha MSH, which is a melanocyte stimulating hormone. The protein switches in the mutation from eumelanin production to phenomelanin production, so a lack of pigmentation shows up in animals and a lighter color will appear. But the mutated and the normal amino acids is located on the inside of the melanocyte cell, just before the cell membrane. So both of them are on the inside of the cell and not in the membrane, and not on the outside of the cell, but in the cell itself. A melanocyte cell is a specialized cell that produces a pigment called melanin, which gives skin and hair its color. Some of the limitations of my 3D model is that it's not as complicated or as complex as the original model/protein itself. There are 3 rows of amino acids within the cell membrane, but for my model, I chose to add the beads to show the bulkiness, which may not have come across as well as the regular 3 rows. I also did not add as many long chains to my project as there would be in the regular protein. There are also different nuances within the different amino acids, which I did not clearly show. For example, the only mutations that I decided to show was the cysteine protein instead of any of the other ones, just to make it a little bit more simple and easier to read. I could also have coordinated the black beads to the different amino acids that were shown throughout the actual mutation itself. But yes, like I said, this is the MC1R protein. Just a few last looks at it. This is the normal, and this would be the mutated.